Hello everybody. In this video we're still talking about the determination of the optimum pipe diameter and of a pipe, and we kind of showed that we can do the calculations by including only the pipe cost for the fixed cost and the electricity cost for the operating cost. And then we added one more item, which is the pump cost, because it's one of the hardware that we are gonna purchase in the very beginning of the project. So we showed in the previous video one method, which is choosing the pump from list of some pumps. We had 8 pumps, and we chose the pump according to its head, and the one that fits with the required head is the one that we chose. And this is the topic of the previous video. In this video we will see another way that we can use to determine the cost of the pump. And this way is kind of I got it from textbooks, where we can find some information about the pricing of the equipment in general, and this will be available in a textbook like this or any other engineering economics textbook. For instance, I'm using the Donald Garrett textbook. There are other textbooks like Peters and Timmerhouse, the chemical engineering economics, or no, it's plant design and economics for chemical engineers, and the Colson volume 6. I think there will be some similar things here. So this is an economics textbook, and it kind of covers a lot of economics things like equipment cost estimation, and this is the topic that we're interested in this video. And there are other things here like the manufacturing costs, some stuff like the interest calculation, profitability analysis, and many things like this. The textbook is 400 and something pages, and we will see that the core or the main text is only 252 pages, and the rest of the textbook, which is 1/3 of the textbook, is appendices. And the appendix that we're interested in is the equipment cost estimates in page 255, and this is what I'm gonna go for now. And it says equipment cost estimates, and it gives you information about how you can give or get an estimate of the cost of the equipment. And this is, it says here, it's a very rough cost estimates of many process equipments, and there is something that I want to highlight here, which is this line, because it's pretty important. It says that all costs were factored to an early 1987 basis. So the price that we are gonna get from this appendix is based on the prices in 1987. Where there was the engineering index number, or the cost index, is 320. We will go through or kind of discuss this in more details in a few minutes, but I just want you to keep in mind that this is an old price. And what we have here are some charts. For each chart you have a parameter here that determines the cost. For instance, this is the absorber. You can define or determine the cost based on the weight of the carbon that you have in the absorber. So this is one thing. You will find many things here that you can choose. There are some agitators. You can find air conditioning, agitating tanks, blenders, blowers, boilers, buildings, even centrifuges, classifiers. There are many things here, but the one that we are interested in is the pumps. So I'm gonna go one by one until I find the pumps. They're very useful for many applications. So I kind of urge everyone to keep this book is available online, so you just keep a copy for yourself on your computer so that you can use it when you want. Anyway, so this is the pumps. There are two types of charts for the pump. One for miscellaneous pumps, which are like the submerged pumps, diaphragm pumps, turbines, positive displacement, reciprocating pumps, whatever. But the one that we are gonna use is the centrifugal pumps. So here there are 3 or 4 charts here, or lines here for the chart, and these lines are for different types of pumps. One of them, and this seems to be the least expensive one of them, it's the conventional pumps. There are axial flow and mixed flow. I'm gonna discuss these in or the differences between these in few minutes. But the point that I want to highlight here is that the x-axis is a combination of two things: the flow multiplied by the pressure, and it says gallon per minute multiplied by psi multiplied by 1,000. So this is not 40, it's 40,000. This is 100,000. This is 6,000, whatever. So the parameter here is not only the flow rate and not only the pressure, and the pressure here is the pump head that you want to, or you want the pump to produce. So this is the multiplication of both, and this kind of takes into account the two parameters that were showing in the previous video about the pump curve. It's the flow rate and the height, or the head of the pump. So it's combining both here in the x-axis with these units, and for whatever type of pump that you want to use, it's gonna give you the cost. So for instance, I'm going for 20,000. It's gonna give me around $4,000 of price. So this is kind of nice thing about this chart. There is one more thing that we need to keep in mind, is that this chart ends at 400 for the flow multiplied by pressure. So it's not valid for higher flow rates or higher flow by pressure values. So this is something that we need to keep in mind. This is what we're gonna use in our case. Let's just, before we go ahead and see how we can do the calculations, just understand the difference between the conventional, the mixed flow, and the axial flow pumps. So first, the centrifugal pumps is a pump that adds pressure or increases the pressure of the fluid by putting energy into the fluid, and this energy will be in the form of centrifugal force, and this is what will come into our minds, and when we hear about the impeller and it rotates, so it's giving centrifugal force, and that's why conventionally the flow will go into the pump and changes its direction to be perpendicular to the original flow direction. So it's going horizontally and then it goes out vertically, and this is pure centrifugal force, and this is why this can give very high heads compared to the other types. So this is the way it works, and that's why this is the first choice when we think about the centrifugal pumps. This is the radial flow, or the conventional flow, is the first thing that comes into our mind. There is one other way, which is the axial flow, where the impeller blades are designed in a way that will make the flow go in the same direction. It's in the axial flow. It's not changing its direction. It's like what we have in the submarines and in the ships, that the impellers push the ship forward. It's not pushing it upward. So this is the same thing. The impellers are designed to push the flow forward. It kind of gives less height, but in some applications you have no choice but to work with this type of impeller. There are other pumps that work with what's called the mixed flow. It's not pure axial and it's not pure radial, so it goes in an angle where it takes some of the axial flow with the centrifugal force from the radial flow. So there is no centrifugal force here, but here there is some centrifugal force with the axial force that comes from the blades. So this is the difference between these three, and this is what we have here: mixed, axial, and conventional flow. Regarding the cost index or the cost factor, this is something that you can understand easily. So if you buy something like 15 years ago, it might be $1,000, and now you want to buy it today, it's gonna be $5,000. So the prices are increasing due to the inflation, due to other factors. So the cost factor is the parameter that we can use to predict the price of something in the current time, based on the price on an old time. So it's let's say I want to calculate the price of something today in 2021, and I know the cost in 1987, like what we have in this chart. So I multiply it by the cost index of the year 2021 divided by the cost index of the year X, where I know the price. So this is just to like take into account the change in prices and to predict the price based on an old price. The cost index is produced or calculated by some, I don't know who exactly does the estimation of the cost index, but it's published every year for each year, and sometimes it's per month. The cost index per month is kind of produced. I usually get it from a website that's called Chemical Engineering Online. You have to be subscribed to or to subscribe to this website and pay like a monthly or annual subscription fees, and that's why you will not find the information easily because it's paid. And that's why sometimes you will not be able to find the price of the current year. You can find 2 or 3 years ago. So now in 2021, I don't know exactly what's the cost index, but I know in 2019 what was the cost index. And this is the cost index that I'm going to use for this video. Sometimes it's published in papers. People do like techno-economic studies or something like this, and they mention that they use the cost index of this year to be whatever the value. So you can kind of search online to find the cost index, but I don't think it's going to be easy to find the cost index of the current year. So usually the latest I found was for the year 2019, which was 607.5. So this is the cost index that I found. Anyway, so this is what we are gonna do for our calculations. Now let's see how we're going to use this chart to calculate the price of or the cost of the pump. So I'm going to go for the conventional pump, and I can see that this is a line. So I can convert it into an equation that I can use to predict the price based on the flow multiplied by the pressure. So I was able to extract the data points from this graph, and just to let you know, I'm gonna post a video about how to extract data from graphs like these in the next video. So in case you are interested, please like wait for it. So the data that I found were the flow multiplied by pressure here, and this is the cost. This is the data from the which are the same as these, the data from the graph. And I tried to do fitting for the data to get like a good way to like explain this or to predict the cost from the flow multiplied by the pressure. And I did it twice. The first time I did the fitting using one equation, which is this, and it gives a very good fit. However, when I checked the calculated values and compared them with the actual values, I found that for the low values of flow multiplied by pressure, the error is very high. So I have 33% error for the very first point here, and it's still very high until I reached the point where the flow multiplied by pressure was around 7 or 8. So the use of the equation in this part is not very good, and I believe because the values are very low here, so the fitting didn't see a very big problem in giving very high fitting R square here. So what I did is I broke the equation into two parts, or the data into two parts, part from 0 up to almost 14 and the rest from 14 till the end. Both give very good fit and the fitted data, and this is how the fitted data are plot against the calculated data. You can see that there is some difference here, and it's not a very good fit, but here in this case you can see the fitting is way better than before, and from the numbers here you can see that the error is not as high as it used to be before. So the maximum is around 5%, which is not very good, but it's not bad either. If you're interested in understanding how I did this, I have already posted a video on how to fit hard to fit data, and I'm gonna put a link to this video in the description of this video in case you are interested. Anyway, so finally, like to make a long story short, this is the equation that I'm gonna use to describe the graph that I have here, which is this graph. What I'm gonna do here is to calculate the pressure multiplied by the flow, and to check if it's valid or not, because some values will be beyond the maximum value, which is 400. So I'm gonna check if the values are valid or not. It's like what we did in the previous video, if there is a pump that can do this or not. So it's the same thing. So what I'm gonna do is multiply the flow rate in gallons per minute, and I have already calculated it in gallons per minute, and multiply it by the head, which is this. But this head is in meters, so I have to convert it into psi, and before I have to convert it into Pascal. So I'm gonna multiply it by 9.81, oops, and then multiply it by the density. So this is in Pascal, so I can convert it into psi. So what I'm gonna do is to use the function that I have already used before, and it's gonna be a good opportunity to apply many things here. So I'm gonna convert this from Pascal into psi. So now I have this in psi, which is the head. So this is the flow multiplied by the head in psi, and then divide this by 1000, because the values are multiplied by 1000. I have everything here, right? So what I'm gonna do is to I think I did something wrong. Oh, the flow rate was not, I didn't press on F4 here. I think something else is wrong. Oh, I clicked F4 on the wrong thing. This has to be constant. It has to be variable, and this is the constant parameter here. So now these are the values that I got. So it seems that there are some values that are very, very high, and at some point I have like 400, which is not what I can use. And again, it's gonna be changed according to the flow rate. So if I use 400, then everything is gonna be calculated accordingly. So anyway, some of them will be valid and some are not. So to do this, I'm gonna check if this value is greater than 400. Then if it's greater, then I'm gonna say skip. It's exactly what we did in the previous video. Otherwise, I'm gonna keep this value. So some of the values will be skipped, and the rest of the values will be valid. And I can calculate cost for these. So the cost will be calculated from the fitting equation that I used before. So I'm gonna paste it as formulas, and from this I have just to make sure that this is from the column M. Oops. So this is calculated from column M, 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 M. Okay, so everything is calculated. However, some of them are giving errors because it's a text, it's not a value. So I can't do what I did before. I think I did something wrong, because I have to multiply everything by 1000, because it is in $1,000. It's not just in dollars. So this is multiplied by 1000. Yeah, the numbers now are more logical than they used to be before. So now for the first values, I'm gonna type if error, and at the end I'm gonna ask it to give the value that it was before. So it's gonna type skip here and skip here. So now I have everything done, and I've already put the formulas before to hide the values that are not valid or skipped point. So finally, I have this graph is plot here according to the new values of the pump. And again, if I change anything in the pump flow rate, or the flow rate, if I make it like 300, for instance, all what I need to do is to click on the calculate button, and then it's gonna give me everything. Finally, it's gonna give me the optimum diameter, and everything will be calculated automatically. There is one important thing that I missed here, which is the cost index. So I have to first I multiplied it by 1000, but I have to multiply it by the cost index of the year 2019, and this is the value that I got, and click F4, divided by the cost index of the year 1987, where the costs were already estimated. So the values will be much higher, and then this is how the cost will be calculated. So now it's all set. You can just click on the calculate button, and it's gonna calculate the optimum diameter and the total cost. The total cost is calculated from the operating cost and the fixed cost. So this is the second way that we can use to calculate the price. Again, the textbook is gonna be very useful in case you are doing any research or doing any calculations to estimate the price of equipment for a plant or for a specific process. So I kind of urge everyone to keep a copy for himself or herself in case you need it. So I hope it helps, and I'll see you in the next video, inshallah. Goodbye.